In this video, we are going to take a look at a bunch of different examples of linear applications, and I'm going to walk you through some approaches on how to solve these on your own. So first and foremost, we have a two trains problem. So it says two trains are 630 miles apart, heading directly toward each other. The first train is traveling at 95 miles per hour. The second train is traveling at 85 miles per hour. How long will it take before the trains pass each other? So the first thing that I would do when coming to a problem like this is I would set up the picture. In other words, you want to kind of draw out what it is you're seeing so that you can map the information you have. That is going to help you figure out what information may still be missing and what information you have for different formulas or equations at your disposal. So here we're talking about two trains that are traveling toward each other. So I would go ahead and start by just simply drawing a couple rectangle boxes. So I've got, say, train A, and then give myself a distance, and over here is going to go ahead and be train B. Now, one thing I know about them is I know that they are traveling towards each other, so my arrows kind of represent the direction. And I also know how far apart they are. So if I start and go a little ways, I know that this is 630 miles to go from one train to the next. Okay, at least that's where they're starting. Now the other pieces of information I have is how fast they're traveling. So we have that one train is going 95 miles per hour. So we'll go ahead and call that train A, so 95 miles per hour, which means train B is going 85 miles per hour. So we'll label that one as 85 miles per hour. Now the question wants to know how long it'll be before they pass each other. So with that, there is one very important formula that we have to be able to use, and that is going to be your distance equals rate times time. So here again, your D is your distance, your rate is going to be the speed, and your time is going to be how long. So minutes, hours, that kind of thing. Now here we are talking about two individual trains. So when I'm looking at my formula, the first thing I need to keep in mind is that this formula is going to be applied to each train. So I have the distance for train A is going to be equal to the rate of train A times the time. Now the other thing that I know is I also know then that the distance for train B is going to equal the rate at train B times the time. Now my rates I know, 95 and 85. Here's the other thing I need to remember. If I have two objects that are traveling toward each other, I have to add their rates together. So the way the formula changes is this is going to become your distance total is equal to the rate of your first train plus the rate of your second train times your time. Well, we know the total distance is 630 miles, so this becomes 630. My first rate was 95, my second rate was 85, and the time is what I'm looking for. So here I'm going to go ahead and add 95 and 85 together, and I'm going to solve for t. And we're going to end up getting that t is going to be 3.5 hours. So it's going to take 3.5 hours for these two trains to pass each other. Alright, so here I've got a problem that says two brothers, Rick and Tom, each inherit $10,000. Rick invests his inheritance in a savings account with an annual return of 2.25%, while Tom invests his in a CD paying 6.15% annually. How much more money does Tom have than Rick after a year? So here we are looking at the formula I equals PRT, where P is your principal, R is your rate, and T is your time. Okay, so the way I like to remember it is P is going to be the money you put in. R is going to be your percent. And T is going to be years. So we have to set this up for each person. So first and foremost, we have Rick. So we need to look at our information about Rick. So here we have that Rick is going to invest his inheritance into a savings account with an annual return. So T equals 1 year. Your R is going to be 2.25%. And your P is going to be the $10,000 that he got. Now when we're talking about rate, it's important that you always interchange it to a decimal. So here, to do that, says you divide by 100, so 0.0225. So to note, you must change percent to a decimal. And here's the important part: do not round. You want to use the decimal as is. Okay, so 0.0225 is what you need to use in your problem. Okay, so we can set up his equation. So we have that the investment equation for Rick, or the interest equation for Rick, is going to be 10,000 times 0.0225 times 1 year. So when we do that, we end up with his interest being $225. Now the other person that we have is we have Tom. We need to look at Tom's information. So here it says that Tom invests his in a CD paying 6.15% annually. So again, here we've got that T is equal to 1. We've got that your rate is going to be 6.15%, and your P is going to be the $10,000. And remember that percent changed to a decimal, so divide by 100, 0.0615. So we need to set up your interest for Tom. Again, is going to be the $10,000 that he receives times the 0.0615 as your rate times 1 year. And we are going to end up with $615. So the question wants to know, how much more money does Tom have than Rick? So we're going to find the difference in my two interest rates. And so here what we actually find out is we find out that Tom has $390 more than Rick. And we found that out simply by taking 615 and subtracting 225, and the difference is how much more money Tom had in his account. Alright, let's look at something a little bit different. So here we have twice a number decreased by 9 times the number is equal to 5 times the difference of the number and 4. So that's a lot of information. So what you have to be able to do with a problem like this is unpack it piece by piece. Okay? So first thing here, I have the word twice. So twice is going to be the same thing as multiply by 2. A number, so this part right here, a number, is going to represent the variable. So this is going to be whatever the variable is you choose. Now I do caution, sometimes you will be told in your problem what variable to use, so you need to be very careful. If it doesn't specify, well, you got 26 letters in an alphabet to choose from, be creative. So that's what the a number is. Decreased by is going to be subtraction. So this right here is to subtract. 9 times the number. So the number, okay, is going to refer to the variable. And which variable am I talking about? I'm talking about this one. Okay, so whatever variable you used. Obviously, is equal to is going to be your equal sign. So when we're looking at it, this very first piece, when you get to your equal sign, this is the first or the left-hand side of your equation. So let's go ahead and write that one down. Twice a number would be like saying 2x. Decreased by means subtract. 9 times the number. So the number refers to the variable we picked. I picked an x. So this would be 9x. And then is equal to. Okay, so that's where we're at so far. So let's look at the back half. We have 5 times, and then I have this thing right here that says the difference of. Well, the difference of means parentheses. Now, what goes in the parentheses? The stuff in the back. Okay, so here we have the number and 4. So remember, when we're talking about the number, so this right here, the number, again is referring to the variable, and specifically the variable we chose in the beginning. So again, we're referring back to this variable here, and 4. Now the other thing that we need to know about it is that what goes into the parentheses is this stuff here in the back. So this piece right here, the number and 4, goes in the parentheses. So how exactly does this all work? Well, let's look at it one more time. 5 times is going to be multiply, so 5 times the difference of. So we're going to open our parentheses here. Difference means subtraction. So we've got the number and 4. So this is going to be x minus 4. Okay, so that's how you set it up. Now the question is actually asking you to find the number. So once you set it up, now you simply need to solve. So here I have 2x minus 9x is going to give you a negative 7x. Distribute the 5, so we're going to have 5x minus 20. And there's a couple things that you could do. We could take the 5x and move it, or we could move the 7 and move the 20. It's totally up to what you choose. I'm going to go ahead and move the 5x just so you can see it, because it involves an extra step. So if I'm going to move the 5x, it is positive to move it, says I subtract. So here I'm going to have negative 7 minus 5 is going to give me a negative 12x is equal to negative 20. Divide everything by the negative 12. We get that x is equal to 20 over 12. And this can reduce. I can take a 4 out of the top and bottom, and this ends up with 5 over 3. So in this case, if we're looking at it, the number is 5/3. In this problem, we are looking for 3 consecutive even numbers such that the following occurs. So right here is going to be our setup sentence. So right here, this is the setup sentence. Okay, so 3 consecutive even numbers. What that tells us is that I have 3 numbers I'm working with. So my first is unknown, my second is unknown, and my third is unknown. We have to start somewhere, so our first number is an n. I want even, which means when I count up, I have to skip over the odd numbers. So my second digit is going to be wherever I start plus 2. Again, you would consider with the patterns, so to get to my third digit, wherever I started, I have to add 4. Now, with that, I have my setup. So I need to set this up the same way we did the other problem by reading it piece by piece. So I have 7 times the second number. So here this is going to start where I have 7 times your second number. Decreased by means subtract. Twice the first. So this is going to be twice the first number. Is means equals 6 times the third. So now that I have my blueprint, let's go ahead and fill it in with my variables. So this is going to be 7 times the n plus 2 minus 2 times the n is equal to 6 times the n plus 4. Now we need to find all 3 numbers, so the first thing to do is we have to solve for our first variable. So we're going to go ahead and do just that. So this is going to become 7n plus 14 minus a 2n equals 6n plus 24. So we're going to go ahead and work on combining. So the first thing that we've got here is we have 7 minus 2. So that's going to give us 5n plus 14 is equal to 6n plus 24. I'm going to take my 5n and move it because it makes life easier. And so here we're going to end up with n equaling, which means my 24 has to be the other one that moves, and this becomes negative 10. So first and foremost, when I look at it, I have to look at my first solution and see if it follows the rule. So I want even numbers. It says nothing about if it has to be positive or negative, so I just simply look at the number itself. And is negative 10 even? Well, yes it is. Since we know it's even, I'm on the right track, so I can figure out what my other numbers are. So my first number was n, which equals negative 10. My second number was n plus 2. So negative 10 plus 2 is a negative 8. And my third number is n plus 4, which gives you negative 6. Alright, last we've got the perimeter of a rectangle is 252 feet. The length is 15 less than twice the width. Find the dimensions. So first and foremost, we're working with a rectangle. So I'd go ahead and draw one. Doesn't have to be perfect. And here, what do we know about rectangles? Well, we know we have a length, we know we have a width. We also know that my perimeter is equal to 252 feet. We've also been given a sentence. The length is 15 less than twice the width. So here, what that's telling us is that I have my length is 15 less than. Less than is a very special phrase. Less than is a turnaround phrase. And what that means is that the stuff here in the back gets written first. Okay, so when we're talking about twice the width, so this piece right here, this becomes first, and then the 15, so this piece back here, this is going to be second, and the less is subtraction. Okay, so again, how does that work? Twice the width is going to be 2w, less than is minus, and then 15. So now we have to try and set up to solve, and we're going to use the idea behind your perimeter to do it. So what we have to remember here is we have to remember that your perimeter is equal to twice the length plus twice the width. The other way we can look at this is 2 times length plus width. Either way is going to get you where you need to go, so it's kind of your choice how you would want to look at it. In this case, I'm going to go ahead and use the top equation, the more spaced out one, just so that you can see it easier. So here my perimeter is 252, and this is going to be twice the length plus twice the width. Well, I know what my length is, so this is 252 is equal to twice of 2w minus 15 plus 2w. Distribute my 2, and I get my 252 is equal to a 4w minus 30 plus 2w. I need to combine my terms, so 252 is equal to 6w minus 30. So in this case, I've got 282 is equal to my 6w. Divide that out and we get that 47 feet is equal to my width. Once you know my width, you can find your length. So if we remember, your length was equal to 2w minus 15. My width is 47, so this is going to be 2 times 47 minus 15. And this here is going to give you 79 feet. So when we're talking about your dimensions, dimensions is going to be width by length. So here we're going to have your 47 feet by 79 feet, and those would be your dimensions. Now notice I included my units of measure. Those are very important, so always make sure you carefully read your problem to see if they give you a unit of measure. If they do, you need to make sure you include it. If they don't, then you would leave it off. But again, be very careful with the problems that you're reading, as some of that stuff is hidden or glossed over. Okay? Now, that is 5 different application problems, all asking you to use the ideas of linear equations in order to solve the different problems. So, as always, if you have any questions, please be sure to let me know. If you come across other application problems that you need help with, let me know those too. I'd be happy to work those out. Otherwise, I look forward to seeing you next time.